In electronics thermal design, a lot of the times what we're concerned about is the junction temperature, keeping the junction temperature below a peak temperature. And we should, because that's directly related to reliability. But there are a lot of products, we see them all the time, that this isn't really the case. The limiting criteria is more to do with the external temperature. So if we consider say a consumer electronics like a wearable watch or something, this doesn't really fall in the world of, hey, thermal design. We don't have to do any kind of exotic thermal design on this because part of the success of this product is that it lasts a long time between charges. So we have a small battery in there. Any heat we're going to dissipate comes from that battery. So we want to have a low drain on that battery. So we're not going to really have thermal problems on the inside. Even though we don't have thermal problems on the inside, we could have thermal problems on the outside. If this is a product we're wearing against our skin, we have to be aware of, and quite often the limiting factor is, what is that external touch temperature? A, we don't want to burn anybody, but B, for this product to be successful in the marketplace, it can't feel warm. So if I'm wearing it and it feels warm to me, I'm most likely going to think that it's a poorly designed product. So what do we do to have this not be too hot on the outside? Well, one thing that can be done is we'll just throttle the performance of this device so it's dissipating less heat, it will cool down. So again, that affects the kind of consumer experience. Well, this thing is too slow. You know, it's either too hot or too slow. So from the thermal design world, it's more of a thermal management world where tools like Simcenter Flotherm and Simcenter FloEFD can tell us, based on how this device is operating on the inside, the power it's generating, what kind of temperatures are we getting on the outside. And because we have the full 3D temperature field, we can look at where would be a good place to monitor the temperature internally to assess what's going on externally and then throttle the device appropriately. So we don't want to throttle it too soon, we don't want to throttle it too late, because both of those things will affect the success of this product in the marketplace. So it's not so much about, yes, the junction temperature. The junction temperature is going to be fine, it's very low power dissipation, but even though it's low power dissipation, it can have a significant effect on the external temperature. And the only way to understand that before you build it is to simulate it with Simcenter Flotherm or Simcenter FloEFD.